Okay, so today we're going to talk about sum and difference formulas. I've given you a pink sheet of paper. It's what I call a foldable. Okay, on this foldable, I have given you our sum and difference formulas as well as examples. This is what I want you to do with it. So I'd like you to turn it to this side. And what you're going to do is along this line on the other side, I would like you to fold it. So you may need to kind of hold it up to the light, but you need to fold it along the line. So it would be like a book opening up with the front being those formulas. Okay, has everyone seen that? You may need to hold it up to the light and kind of hold it like this. But the formulas need to be the front of your book. If you want to fold it on the inside and then fold it back the other way, that's fine, whatever works. So on your foldable, you have three formulas. These are called our sum and difference formulas. Okay, so let's just talk through these very quickly. So this is if you have a sum or difference inside of one of your angles. So if we have the sine of angle U plus angle V, then we can rewrite that as the sine of U times the cosine of V plus the sine of V times the cosine of U. Okay? Do you see how it's a plus minus here and a plus minus here? That means to apply this formula, if it's addition in here, we use addition here. If it's subtraction here, we use subtraction here. Now, the cosine one looks kind of funny, doesn't it? We have the cosine of U plus or minus V equals the cosine of U times the cosine of V minus plus the sine of U times the sine of V. What that means is if this is addition, if it is the cosine of U plus V, then we're going to apply the formula with subtraction. If this is the cosine of U minus V, then we're going to apply the formula with addition. So when you have that minus plus, that means you have to use the opposite sign of what you started with. Okay? Then you see here we have the tangent formula, the tangent of U plus or minus V. To apply that, we're going to take the tangent of U plus or minus the tangent of V over 1 minus or plus the tangent of U times the tangent of V. So here we have both signs, okay? If we're talking about the tangent of a U plus V, we would use addition in the numerator, but subtraction in the denominator. And then vice versa if we have subtraction. Okay? Is everyone clear on what those signs mean? Okay? And we'll get to practice each of these formulas twice inside of your little foldable. But what I'd like to do first, okay, I would like to prove one of these formulas to you. Okay? You are very trusting people. I sit up here and I tell you a lot of things about math that you never knew before. And you just trust me and you say, yeah, okay, if Mrs. Quinn says it, it must be true, right? Well, in math, we like to prove things are true, okay? You did that in geometry. Some of you didn't enjoy it, okay? If any of you are interested in upper level mathematics, like beyond computational math, beyond calculus and differential equations, then you actually need to take classes where you prove a lot of these things that we've talked about for years and years. Okay? So what I'm going to do is I'm going to take a break here in the video. Okay, we are back. So what we're going to do, we have two examples with each formula. Okay? So we can go to a formula, open the flap, and we have an example. And you have the formula on your foldable to refer to. So here is our first example. Okay? We want to find the exact value. Now, if you punch this into your calculator, the sine of pi over 12, you're going to get a number, but it's not going to be exact. Okay, it's going to be approximate. If it's a decimal, that's going to go on forever. So instead, let's think of two angles that either add or subtract to pi over 12. Two angles that add or subtract to pi over 12. Angles that we know things about, like pi over 3 and pi over 4 and pi over 6. Think about adding or subtracting any of those to make pi over 12. Okay, if you're saying we did pi over 3 minus pi over 4. Okay, let's think about making common denominators. This would be 4 pi over 12 minus 3 pi over 12, and that would get us pi over 12. Do you agree? Okay, so the sign of pi over 12 would be the same as the sign of pi over 3 minus pi over 4. Okay. So now reference your formula. Okay, the sine of u plus v is the sine of u cosine of v plus the minus the cosine of u sine of v. All right, so this is going to be the same as the sine of pi over 3 times the cosine of pi over 4. Since it's subtraction, we keep subtraction, and now we say the cosine of pi over 3 sine of pi over 4. Okay, this formula will keep your angles in order. Okay, pi over 3, pi over 4, pi over 3, pi over 4. Okay, so now we've applied the formula. All we have to do now is simplify. What is the sine of pi over 3? Gotta go 3 over 2. What's the cosine of pi over 4? Minus. What's the cosine of pi over 3? 1/2. And the sine of pi over 4. Okay. So what this means is we have, what is the square root of 3 times the square root of 2? So we have the square root of 6 over 4 minus the square root of 2 over 4. So I would just ask that you write this as one fraction. The square root of 6 minus the square root of 2 all over 4. That is the exact value of the sine of pi over 12. Questions? In your homework, you will have some problems where they will tell you which angles they want you to use. There will be some problems where you will have to come up with the angles you need to add or subtract to get the angle they're asking you to evaluate. Okay. Okay. Next example on your foldable. It says find the exact value of blah, 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 blah. Now, we can easily sit here and evaluate the sine of 120, and evaluate the cosine of 60, and evaluate the cosine of 120, and evaluate the sine of 60, and put it all together. Or we could recognize that that means what? Okay, if you notice, this is the difference formula for sine. So this really means the sine of 120 minus 60, which is really the sine of 60. And Kyler, what is the sine of 60 degrees?
That's a good question. It's going to be that view over here.
Okay. Yes.
So how do we get to sine of 160 minus, or 120 minus 60? How do we like put out the cosine?
Okay, well, if you look at this compared to your formula on the front, cosine of an angle, cosine of another angle, minus cosine of an angle, sine of another angle, that is just verbatim the difference formula for sine. So we know we can rewrite it as the sine of the difference of the two angles. Okay, so you will need to be able to look at something and recognize which formula is being used so you can rewrite it. Okay, I guess I should say this. You'll get these formulas on the quizzes and tests. Okay, I'm not going to make you memorize these three. All right, probably tomorrow I'll write them on the board for your quiz. Okay, and then Tuesday for your test, we'll learn more formulas on Friday, and they'll just be like on a note card for you. Okay. All right, let's go to our second flap, our cosine formulas. Okay, you're going to get some problems that look like this. Simplify this expression. Okay, well, this is a cosine, and inside of cosine, we are adding two angles. So this is the sum of a cosine, and we can break that up using our formula. So help me out. Look at your formula. Okay, now let's write it. We first take the cosine of the first angle times cosine of the second angle. If it's addition inside, what do we use for our formula? Subtraction. And then we do the sine of the first angle, sine of the second angle. Okay. Now, we obviously can't rewrite the sine of theta or the cosine of theta, but we can evaluate the cosine of 3 pi over 2. What is the cosine of 3 pi over 2? 0. And what is the sine of 3 pi over 2? What, Josie? -1. So the cosine times 0 goes away. And we have negative sine of theta times -1. So this just simplifies to the sine of theta. Questions there? As long as you know how to apply the formula, this isn't going to be too bad. All right? Okay? We're going to verify this identity. Okay? This is called a cofunction identity. We didn't learn about cofunctions. Sine and cosine are cofunctions because their graphs look the same. They're just shifted a little bit of each other. Okay? But all we need to worry about is being able to apply this formula, or to verify this identity. Obviously, we're not going to start on the left side, the right side. We need to start on the left side. We have a cosine with a difference inside, so we can use our difference formula. So let's do that. we have cosine. We're going to take the cosine of pi over 2 times the cosine of x. And if we're subtracting inside of our cosine, what operation will we use in our formula? Addition. And so then we write the sine of pi over 2 times the sine of x. Remember, this is an identity that we're proving. So I'd like you to tell me what you did. Okay, we used cosine difference formula. Okay, so now what do we need to do with the left side to get this to verify?
Change cosine pi over 2 and sine pi over 2.
Okay, Sean, what is the cosine of pi over 2?
Sine pi over 2 is 0.
0. And the sine of pi over 2. Matthew, what is it? Good. Okay, so on your reasonings, we can just write, we evaluated those trig functions. So now what's 0 times cosine? 0. 1 times sine? And we multiply, so I'm going to write that as our reasoning. Okay? So these are actually kind of nice, because all you have to do is apply that formula and then simplify it, and you're done. Okay? So these identities are a little more straightforward to verify when you get to use that sum or difference formula. All right, 2 more examples. We're almost there. The next 2 deal with tangent. Go ahead and flip back on your flat, blah, blah, blah. Look at your tangent formula. Okay, this one has a little bit more going on. So all I want to do is simplify this expression. Okay, so to apply our formula, first of all, what's happening inside of our tangent?
Addition.
We have addition. So to apply the formula, we're going to take the tangent of the first angle plus the tangent of the second angle over, then we have 1. Do we use minus or plus? Minus. Tangent of the first angle, tangent of the second angle. Okay. Tangent of theta we can't really do anything with. What is the tangent of 3 pi? Let's talk about where 3 pi is. This is 0 pi, 1 pi, 2 pi. Here would be 3 pi. Right, if you went around 1.5 times. Okay, so the tangent of 3 pi is 0. Okay. I do want to see you substitute those zeros in. Okay. And just flash back to the last example. I do want to see like that 0 and 1, like that has to be a step. I do need to see that substitution before you go straight to this is the tangent of theta over 1. Okay, we have saved the best for last. I want the tangent of 255. That's not a special angle. what we need to do is we need to figure out two special angles that either add or subtract to 255 so that we can use the sum or difference formula and then our unit circle values. So think of all of your 30, 45, 60, 90, 120, 150. Okay, Michaela has suggested 225 and 30. Do those add up to 255? Okay, so this is the same as 225 plus 30 degrees. I'm going to go ahead and tell you you're going to want to write small. Okay, this is going to take a few steps. All right? So, let's do this. To apply our formula, we have the tangent of 225 plus the tangent of 30 all over 1. Since we already used addition, we're going to use subtraction, tangent of 225, tangent of 30. Okay. What is the tangent of 225? 1. Okay. It would be positive because it's in the third quadrant. Plus the tangent of 30. Radical 3 over 3. Over, we have 1 minus tangent of 225, we decided was 1. 1 times radical 3 over 3. Am I going to let you leave your answer like this? You wish, right? Unfortunately, there's a lot of bad things happening. Number 1, there's a radical in our denominator. Number 2, we have fractions inside of fractions. Okay? So this is my suggestion. First of all, we have to get rid of the radical in the denominator. And what is our strategy when we have a binomial that includes a radical in our denominator? We multiply by its conjugate. So we are going to take the denominator and multiply it by 1 plus radical 3 over 3. And then we also have to multiply that to the numerator. Do you notice how I'm putting everything in parentheses? It's because we're multiplying binomials. Everything has to be multiplied to everything. Okay. All right, here we go. Talk about our numerator. 1 times 1 plus 1 times radical 3 over 3 plus radical 3 over 3 times 1. Okay, so I'm going to say that we have 2 of those, right? Plus, what's radical 3 over 3 times radical 3 over 3? Huh? 3 over 9, which is 1/3. Okay, then let's talk about our denominator. Our denominator, we have 1 times radical 3 over 3, negative radical 3 over 3 times 1. Those cancel out, and so we're left with minus 1/3. Okay. All right, so this is what we have. What is 1 plus 1/3? 4/3. So I'm going to write our numerator as 4 plus 2 radical 3 over 3, because we have 4/3 plus 2 radical 3 over 3. Divide by, what's our denominator? 2 over 3. here's where it gets fun. I'm going to write this out for us here. We have 4 plus 2 radical 3 over 3 times the reciprocal. So what happens to our 3's? They cancel. What's 4 divided by 2? Plus 2 radical 3 divided by 2? Radical 3. Okay, that was a little work. No matter what, this tangent formula, when we're doing problems like this, it will create a little bit more work because we're going to get that radical in the denominator. Now, here's my suggestion. Using the tangent of 30 degrees created a little bit more work because of that fraction. When you can, try to use the tangent of 60 degrees because it's not a fraction. Okay? Is it bad to use the tangent of 30 degrees? No. But if there's a way for you to use tangent of 60 degrees, it'll be less work for you. Okay? So here's your homework. I know it feels like there's just a lot of random numbers thrown up there, but I wanted to make sure you got enough examples of each type of formula. Okay? Now, you kind of have no choice but to do your homework tonight because we're going to have a quiz tomorrow. Now, we will have an opportunity at the beginning of the class. You'll ask me questions. We'll go over problems. It's going to be a short quiz, so I'm only going to use half the period for it. So we'll have time to answer questions, go over problems, not only from this assignment, but anything from 5-3 if you'd like. But we will have a quiz. Okay. Are there any questions?